Okay, theorem 10.9 is tangent and chord. So guess what we have to draw with the circle? It's not rhetorical. A tangent and a chord, yes. So let's draw circles with the center. Carson, how do I draw a tangent line? Yes. So let's say it touches right there. Jody, drawn? Yeah? Touch it only at one point. Boom, right there. So this is my tangent line right there. Let's label it D, C, and this side would be E. Okay. Now I'm going to do a chord from point C. And what's the restriction on a chord? Can I do this? No. Can I do this? Technically, yes. But they was supposed to be a diameter. It's just a special chord. But I have to touch 2 points on a circle. So right there. We'll hit those 2 points. Right there. That's all we're talking about. We'll call this A. And this will be P. And just so I can decipher major and minor arc, let's call this down here B. Okay, my relationship that we're going to talk about is between this angle and this arch right here. So arch AB. No, arch AC. So I'm just going to write this. I'm not going to actually do the long Woody version. Do we like Woody versions of theorems? Or do we like just like this angle equals this? Or this implies this? Or do we like words? I hear Ashley's opinion. I don't hear anyone else's. What? That one? Okay, so not Woody. Okay. So when we were talking about inscribed angles, what's its relationship with its arc? Look back at your notes. We've been talking about inscribed angles this entire time. Inscribed angle, what is its relationship with its arc? You too, Carson. Look back at your notes. An angle inside of a triangle and its intercepting arc have a relationship. Inscribed angle. So something that looks like this. If I said that, got 2 examples. How is this angle related to this arc right here? Vincent, look back. Don't sit there waiting for someone else to answer. Lily, do you know the relationship? The angle is half the measure of the intercepted arc. Yes, so if this was x up top, if our arc was x, then our angle is half of x. So if we're going this way. If we're going the opposite way, this arc would be double the angle inside. Guess what? This same idea applies to this image right now. This angle is going to be half of this arc that's inside of it. Okay? So angle ACD is half of the measurement of AC. This minor arc right here. So all of this guy. And that's my angle. Ooh, that was bad. So same idea. I know it's not inside, but it's the same idea. It's the same theorem. So when I have a tangent and a chord that intercept at the same point, the arc is going to be twice that of the angle. We can flip it the other way. So if I did it the other way, then the measurement of AC is twice that of angle ACD. just going the other way. Multiply both sides by 2. Yep. Okay. Let's do an example of this one. Want easy, hard one, or middle? Middle. Okay. I have a circle. I have a center. Let's draw the same image as we had above. We have a chord. Vincent, are you writing this? Yep, good. Thank you. Then we have a tangent line that passes right through it at exactly 1 point. So this is my tangent line. This is my chord right there. Let's label this. Let's call it A, B, C. Circle will be circle P, and the chord also touches from B to D. Okay. I'm going to tell you that ABD, this angle right here, is 16x plus 4. That's that angle. This arc right here from, let's add another one. Let's say this is E. So B, E, DEB, the measurement of that arc, we're going to say is 38x plus 2. So this entire arc is 38x plus 2. Why don't you find what x is? Find x. Okay, what is the relationship between this entire arc and this arc right here? I have a major and minor arc of a circle. What does all the arcs of a circle add up to? Great, okay. We have 360. 360. I have to add, that's what happens when I add up DB and measurement of DEB. Which one do we already know? Which arc do we already know? Yeah, we already know DB, which was 38x plus 2. We need to find the arc of DB. Use your theorem above to help you find what it might be. You're not going to get a certain number right now, but it's going to be expressed as an expression. Okay, I see some of you have it. What is the relationship between arc, DB, and this angle right here? Raylene, what's the relationship between these two? Arc, DB, because that's what we're trying to find right now, and this angle right here. So it's the same thing here. This angle and this arc have a relationship to each other. Yep, it's half of it. So how would I write that expression? So I gave you my angle. So I can have the angle right here. So plug it into this one. Yeah, because I want to figure out what my arc measurement is, right? And I gave you what the angle is. 16x plus 4. So what should this equal to on this side? We should have 2 and then our angle, right? Yeah, 16x plus 4. Perfect. And after, so that's what that arc equals to. So now we have 16 times 2, so 32x plus 8 plus 38x plus 2 all equals what, Vincent? What does this all equal to if I'm adding two arcs together? They make a full circle. What's going to be on this side? Yep, 360, because the whole entire circle is 360 degrees. Yeah? Okay. Keep doing the math. See what you get. Bless you. So x would have been 5. Vince, is that what you got? X equals 5. So this would have been 10 plus 4070x over 360 minus 10 from both sides. I get 350 equals, yeah, equals 70x. Then we should divide 70, right, from both sides? Yep, and then I get x equals 5. Do you want an easier or harder problem? Easier? Okay. Next one. Let's do a circle, right? A circle. And I gotta draw two things. Raylene, what do I have to draw in these problems? Yeah. A tangent and a chord. We'll do that right there. Okay. Yep, this angle right here is going to be 126 degrees. Plus A, B, C, and D. I want you to find the degree measurement of arc AB and ACB. I want to find both arcs of the circle and what both arcs should add up to 360. So now we're at full circle. It's a good way to check to see if you're right. don't think my image looks very close to what the actual answer is going to be, but, right? Yeah. What do I have to do to the 126 to find the arc in between those two? What do I have to do to this angle? Yeah, multiply by 2. So the first one is 2 times 126, and I should get 252. Vincent, what do I have to do next to get my second one? If this is all 252 degrees. So I have both sides of my arc. If this entire thing right there, that would, if I added those two, we would get what? Yep. Okay, if I already have one and I want to find the other, what do I have to do? Subtract it by 360. Yep, to get the other half of it. So when I subtract these two, what number do I get? 108. Perfect. So full circle adds up to 360 degrees. Let's add that in if we don't have it. A circle is 360 degrees. So that's a full circle. Okay, want a harder one? You want to do a harder one up on the boards or at your seats? That is so true. So, let me give you homework. Homework 10.4. We've been doing this for a few days. So it's about all out inscribed angles. Page 453. We can do 22 to 31, and 35 is a word problem. Okay. Those are your questions. You can start now if you want and ask me anything if you want. Or you can just